In this episode, we're going to tackle a part of Git that beginners often ignore until something breaks: configuration. Git configuration is not glamorous, but it quietly shapes how every commit is labeled, how your tool behaves, and how your local work connects to shared repositories. When Git is misconfigured, you can still type commands and see things happen, but the outcomes can be confusing, inconsistent, or even risky for a team. This matters for automation work because the repository is usually treated as a source of truth for what can be deployed, and you want that truth to be traceable and reliable. If your commits have the wrong identity, your remotes point to the wrong place, or your default workflow settings clash with the team's expectations, you create friction that shows up as wasted time and accidental mistakes. Getting configuration right is like setting the foundation straight before you build anything on top of it. Before we continue, a quick note. This audio course is a companion to our course companion books. The first book is about the exam and provides detailed information on how to pass it best. The second book is a Kindle-only ebook that contains 1,000 flashcards that can be used on your mobile device or Kindle. Check them both out at cyber.author.me in the Bare Metal Study Guide series. The first category of configuration is identity, which is how Git labels your commits with a name and an email address. A commit is not just a snapshot of code. It is also a record of who authored the change and when it happened. In distributed teams, that identity information is how people ask questions, request clarifications, and assign responsibility in a healthy way. If your identity is blank or incorrect, your commits may appear as coming from an unknown person or the wrong person, and that breaks accountability and auditability. For beginners, it can feel like identity is just a cosmetic label, but it is actually part of the project's historical record. When automation changes are reviewed after an incident, correct authorship can save hours because it points to the person who can explain the intent. Clean identity settings make collaboration smoother because your teammates can trust the metadata that accompanies your code changes. Identity also matters because many organizations apply policy based on email domains or verified accounts. Even if you are not dealing with formal policies yet, the concept is useful. Correct identity settings help the system know that your commits are truly yours. A mismatch can cause your changes to be rejected by remote rules, or it can make your work appear in the wrong category when the team reviews history. Another subtle issue is using different identities across machines, which can make it look like multiple people are contributing when it is really just you switching laptops. That can confuse tracking and analytics, and it can complicate audits. The beginner takeaway is to set your identity once, verify it, and then be consistent across the environments where you work. Consistency is a recurring theme in deployable automation, and Git identity is a small but important piece of that consistency. The next category is remote configuration, which controls how your local repository finds and talks to shared repositories. A remote is essentially a named address, and if that address is wrong, everything you do will be pointed at the wrong destination. Beginners sometimes copy a repository URL from a browser and assume Git will figure it out, but Git needs a precise configuration that matches the actual remote repository location and the access method you are using. If your remote points to an old fork, a training mirror, or the wrong organization, you might push changes where nobody sees them or pull changes that the team is not using. In automation work, that kind of mistake can lead to deploying the wrong version of code because different systems are watching different repositories. Correct remote configuration ensures that when you synchronize, you are synchronizing with the place the team considers authoritative. Remote configuration also includes how authentication is handled, and while you are not doing step-by-step setup here, you should understand why it matters. When your authentication method changes, Git might suddenly stop being able to pull or push, or it might prompt in unexpected ways that break automation workflows. For example, some environments are non-interactive, and they cannot respond to prompts, so authentication must be predictable. Even in interactive use, inconsistent authentication can lead to confusing errors that look like network problems but are really credential issues. A clean configuration mindset treats authentication as part of the reliability story, not as an annoying hurdle. If the remote connection is reliable, you can coordinate changes smoothly, and that coordination supports predictable delivery of automation updates. When the remote connection is flaky, your workflow becomes a series of interruptions, and workarounds. Another part of configuration that trips beginners is the default branch name and how Git decides what branch is considered the main line of development. Different repositories may use different conventions, and a mismatch can cause you to push to the wrong branch or create branches that do not align with the team's expectations. This is not just a naming preference. It affects how people interpret history and where automated systems look for deployable code. If the team's pipeline deploys from a specific branch and you accidentally direct your work elsewhere, you can end up with a situation where code exists but is not being used. Configuration settings influence the default behavior of commands that create, switch, or synchronize branches, so small misunderstandings can cascade. The beginner goal is to understand that defaults exist and they can differ between projects, which means you should verify the repository's conventions and align your settings accordingly. When your defaults match the team's reality, your everyday workflow becomes simpler and less error-prone. Workflow settings also include how Git performs integration when you synchronize with a remote. Some workflows prefer merges, some prefer rebusing, and the difference affects how history looks and how conflicts are resolved. The important beginner point is that Git can be configured to behave differently for the same high-level action, which means two people can run what sounds like the same command and produce different history shapes. That difference can create confusion during review and troubleshooting because the commit graph might look unfamiliar or unexpectedly complex. For deployable automation, consistent history is helpful because it makes it easier to trace changes and understand what code is in production. If your Git is configured in a way that fights the team's conventions, you might repeatedly create history that others find difficult to follow. Clean configuration means your tools reinforce the workflow rather than constantly pulling against it. Line endings are another configuration area that seems minor until it creates noisy changes. Different operating systems sometimes represent line breaks differently, and Git can be configured to normalize line endings or to preserve them as is. If this is misconfigured, you might create a commit where it looks like every line in every file changed, even though you did not alter the actual content. That kind of noise is harmful because it makes real changes harder to spot, and it increases the chance that a subtle automation bug slips through review. Noisy commits also make blame and history inspection harder, which matters when debugging. A clean configuration approach reduces these accidental mass changes by ensuring that the repository's expectations for line endings match your environment. Even if you do not understand the technical details yet, the concept is simple. You want Git to record meaningful changes, not meaningless formatting differences. Another place configuration matters is in ignoring files that should not be committed. Many projects have local artifacts like temporary outputs, caches, or environment-specific files that are not meant to be shared. Git relies on ignore rules to keep those artifacts from cluttering the repository, and the effectiveness of those rules depends on consistent configuration and team discipline. For automation, accidentally committing local secrets, generated files, or machine-specific settings can break deployments or create security incidents. Clean configuration and good habits help you avoid those mistakes by making it obvious which files are tracked and which are not. Beginners sometimes assume Git will automatically know what to ignore, but Git only follows the rules that exist in the project and your environment. Understanding that ignoring is an intentional choice reinforces the larger idea that deployable automation requires controlled inputs, not random local residue. Git configuration can also influence how you see information, which affects your decision-making. Settings that control display, diff behavior, and default comparisons can make it easier or harder to understand what changed. If your diff view hides important context, you might miss a risky change in automation logic. If your status view is confusing, you might commit the wrong files. For beginners, it's enough to recognize that Git is highly configurable and that those configurations are not neutral. They shape your perception. A good practice is to keep your configuration understandable and aligned with the team, so when someone gives you guidance, you see what they see. Shared understanding reduces friction, and reduced friction makes it more likely that people follow safe processes instead of rushing. In operational automation, rushing is where mistakes sneak in. Misconfiguration often shows up as repeated small frustrations, like constant prompts, unexpected conflicts, commits attributed to the wrong identity, or pushes going to the wrong place. Those frustrations are not just annoying. They are signals that your foundation is shaky. When you ignore them, you start building habits around workarounds, and those workarounds can become unsafe shortcuts. A clean mindset is to treat early configuration issues as opportunities to stabilize your workflow. If you make Git predictable, your day-to-day actions become predictable, and that predictability is the soil where good engineering habits grow. Beginners benefit from this because it reduces the feeling that Git is random or hostile. Once Git behaves consistently, it becomes easier to learn because cause and effect are clearer. The big picture is that correct Git configuration supports three things that automation teams care about: identity for accountability, remotes for coordination, and workflow alignment for predictable history. When those three are stable, the repository becomes a reliable record of what changed and why, and automated systems can trust it as an input to build and deploy processes. When they are unstable, you get confusion, duplicated effort, and sometimes accidental changes reaching the wrong place. For brand new learners, the goal is not to become a Git administrator, but to understand that configuration is part of quality. It is the difference between a tool that helps you think clearly and a tool that keeps surprising you. When you configure Git correctly, you avoid a whole class of mistakes that are preventable, and you give your automation code the stable collaboration foundation it needs to remain deployable over time.
Thanks for listening. For more audio courses, daily newsletters, and more, please visit DailyCyber.News.